Welcome back, my friends. We're going to do a couple more examples of the first derivative test. It's a test where we use the first derivative to find any maximum point, any minimum point, or find out where a graph is increasing or decreasing. The first function is behind my head right now. Let's go ahead, find the critical values, make a sign chart, and figure some things out. So I found the derivative. I used the quotient rule. It's a grand rule. We love it. What's going to make this this derivative, either zero or undefined? This one's definitely going to have some undefined points. If the denominator of a fraction equals zero, that's undefined. So I set the denominator equal to zero, solved it, and I got plus or minus 3. That's two of my critical values. What makes a fraction equal zero? What makes this derivative zero? Well, if you want to know what makes a fraction zero, that's if the numerator equals zero and the denominator doesn't. So now we have our critical values. Make a sign chart. That's my setup. Those are the intervals. I created my intervals by looking at these critical values here. And I like to write it this way. This helps me understand exactly what it's going to look like. Now pick out any single point in any of those intervals and plug it into the derivative. You plug it in the derivative, you'll find out if the slope is positive or negative. Now, sometimes there are some tips and tricks that you can do with these. For instance, when I looked at this, I realized no matter what I plug in the denominator, since it's squared, the bottom half of that whole derivative is always going to be positive. All I needed to do was plug numbers in to the numerator to see what that would be. But here's what I have. Notice this breaks the trend of alternating every time. So exactly what does this mean? Let's get to the questions. Well, if I'm going by these questions, common sense gets a little bit murkier. The first one's easy enough. What intervals is the function increasing? And if the derivative is positive, it should be increasing on these exact intervals. Now, could I combine those? They both stop at -3, and the answer is no, I'm sorry. We already know at -3, the slope is undefined. Something weird is going on there. Then we get to determining all the extrema, and we realize, gosh, what do we know? If it's increasing, and then suddenly it's increasing again, is that a maximum? Something's going up. For a second, it's undefined, and then it goes up again. Was there a maximum or minimum there? It's only when increasing and decreasing intervals change from positive to negative or negative to positive. We have one extrema on this graph, and it happens to be at, it's a maximum at 0. And how do we find out where it is? What's the height of this? We know the x-coordinate 0. We have to go up to the original function to find the y-coordinate. The fact that this says y equals, big hint. Yeah, go for it. You plug it in and you realize that's 0, 0. Now this is kind of a confusing graph. Why would it go up and then go up again? If you see the whole picture, it makes more sense. But we can kind of put a picture together. Why, ladies and gentlemen, there were some asymptotes there. That's why the derivative was undefined at -3 and 3. As a matter of fact, the actual function is also undefined there. Sometimes graphs can be a little misleading, but if you use these sign charts, you can tell exactly where the extrema are and what they should look like. Let's try one more crazy example. This is a crazy example because the derivative is just nasty. Sorry about that. It happens sometimes. But we're still going to find the critical values, make a sign chart, and use common sense to put all this together. Let's try it now. Here's the derivative. I used the product rule. I also had to use the chain rule to get to that. I wound up with two different terms, so I crossed out a 2 here, divided it out, and I found a common denominator, allowing me to then find my critical values, anything which makes it undefined or equal to 0. That's a big, long, messy chart, but it's right. And I find out something really interesting here. The actual domain of this function is only from -5 to +5. There's nothing in those intervals because the graph doesn't exist there. And the extrema are identified.